Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem, problem 290, word pattern. In this video, we're going to explain a solution based on index decomposition. First, I'll read through the problem statement, and then we do the analysis, and finally, we translate the analysis into code. First, the problem statement. Given a pattern and a string s, find if s follows the same pattern. So here follow means a full match, such that there is a bijection, that is 1, 1 and onto, between a letter in pattern and a non-empty word in s. So here are three examples. So in example 1, so the return is true. So we can make A correspond to dog and B correspond to cat. So in example 2, so the return is false because we have a fish here, right? In example 3, so we also return false. The reason is that in the pattern, all the 4 letters are the same. While in S, if we split this S, so we have dog and we also have cat. So with that said, let's also look at the constraints of this problem before we do the code and analysis. First, the length of the string pattern is bounded above by 300, so which is not a very large number. Secondly, pattern contains only lowercase English letters. And similarly, S has length bounded above by 3000. So S contains also lowercase English letters and spaces. So S does not contain any leading or trailing spaces, and all the words in S are separated by a single space. So this actually provides the separator for us to use the split method of string. So with that said, we are ready to do the analysis. So for this problem, here what matters is the indices decomposition. So here let me use example 1 to fix the idea. So here A is at indices 0 and 3, while B is at indices 1, 2. So similarly in S, dog is at indices 0, 3, and cat is at indices 1, 2. So they both have index decomposition or indices decomposition 0, 3, and 1, 2. So here we implicitly used the sorting of the decomposition for correspondence. So the actual correspondence for this example is A corresponds to dog and B corresponds to cat, though it's not necessary to be known for solving this problem. So with that said, we are ready to translate the above process or idea into coding. So in order to make it modularized, I'm going to write a hyperfunction to do this. So the hyperfunction is going to for indices decomposition, right? So here I'm going to define it as decomposition. Decompose, let's use verb. So here we can accept an iterable. So this item can be a string and it can be a string like this, right? So then we're going to initialize a dictionary. And then so for I and Y in enumerate item. So here we are using enumerate is due to the fact that we want to do indices decomposition. So the index is important for us. And then we're going to do the standard check if Y not in D. And then we're going to set dy equals the single element list. So here I'm using list. So otherwise, so we're not y. So here index I, right? And then we're going to append the current index into this key, the value corresponding to this key y. So with that said, what we return actually, in order to make the correspondence, we need to do a sort. So we can do sorted d values, right? So this way, so we use like this order, right? So the smallest one. So with that said, we are ready to do the return with the problem logic. So here, notice that S is separated by a single space, right? So here, first we can get the decomposition for decompose for the pattern, right? So this is the string. So we just do the decomposition in the character level, and also we need to do the decomposition for the S, but it's in word level. So let's use S split. So the split will give us an iterable. So then we can call this function. So what we want to return is to check if these two at least are the same, or in other words, if the two decompositions are the same. So this actually forms a full solution format for this daily challenge problem. Let's do a check. Yeah, it passes the first example. Now let's check another one just for double safe. So let me check this one. A, B, B, B. So let's see. So this should return false, right? So with that done, let's check the generic case. Yeah, it passes all the test cases. So here, we would like to make some comments to end this video. First, so the key here is the index decomposition. If we use this solution, follow this solution format or thoughts, this is the one point. Another point is that so in the process of writing the decomposition function, so we used the enumerate function. The reason is that the index is important for us. So this is another point. And finally, so we used the split method for a string. So here, due to the problem assumption, so the words in S are separated by a single space, right? So if the words in S are separated by some other separate, you need to specify here in the argument of the split method. So with that said, I guess that's about it for this easy daily challenge problem as marked by Leetcode. Thank you.